Well, thank you, and good afternoon myself. So I was asked today to talk to you about the Microsoft Cloud and, like he said, about how to achieve highly scalable applications. And my session will be about a strategy we call microservices, another approach to building applications, but also making them scalable, and where Microsoft as a platform can help you achieve that. Before we do, I'd like to understand who's in the audience. Who does consider him or herself to be a developer? Okay, majority. Okay, good. Well, then I chose the right subject because normally I tend to talk to an IT pro audience, which is a bit different to me, but we'll talk about apps and how our platform can enable you today. So my name is Maarten. I'm a Microsoft MVP, also what they call a regional director, which is a community title. So I get to speak at a lot of conferences like these and share some of those experiences I gain by doing projects. Before we do, I'd like to ask a question like, why do we want to achieve scale? Of course, we want to achieve scale because of the new economy, because there are no physical barriers anymore. The applications we're writing for web shops or other business purposes need to scale unlimited and need to also scale with the company growth and in general with the economy growth. So we're trying to achieve ways of building platforms so that we can run these applications at scale. For instance, when you want to do web shops commercially, etc. Now, Microsoft has a cloud offering, and I'm betting that at least everybody has heard about Azure. Maybe some of you have already tried Azure. And Azure is a general term because under this umbrella, a lot of services are provided by Microsoft, both in a public way as well as on-premises through something we call Azure Stack, and we'll come to that later. But also hosted parties can take this, provide these services so that all these interfaces, all these APIs, the way of working, how we provide these services are consistent between the public cloud, the hosted cloud, and the cloud running on premises. Now, the key drivers behind this is that we want to run them at hyperscale, so certainly at a public cloud, at a hosted cloud offering, so that we can scale with you as long while your company grows. We want to do that not only for consumers and consumer services, but also for enterprises, where we provide them with what they need on security, identity, all these kinds of subjects. But also in a hybrid way, because Microsoft recognizes that in lots of cases, you run our services today in your data center or in a hosted data center, and you might be using some of these public services where scale really matters. For instance, like Azure Machine Learning, which might be hard to run in your own data center. So Microsoft's vision is that you have choice where you run Azure, and Azure would be in a public or hosted offering, but you can run it on premises in something that we call Azure Stack that will be coming generally available later this year. Now, Azure Stack takes these learnings from the public cloud at how to do this, but also takes the code, literally the code they run, Microsoft runs in the public cloud, and offers them to you to run on premises. Of course, that will require you to have quite a bit of requirements based on the hardware you'll be running, but certainly providers such as LeaseWeb will be coming out with certain kinds of services that provide you with this consistent API, the way you can work with Azure in your way. Now, if we want to talk about apps, I'm not going to consider the infrastructure as a service option for now. You could certainly probably use that at scale and provide automation. You can maintain it so that it runs at scale. But I'd like to talk to you about the microservices approach, where you take the application that you want to run, the platform you want to run, and more or less split it in all kinds of small pieces that you then independently maybe develop and publish to these platforms. Why do we need a Microsoft services approach? Because we want to run these platforms at scale. Secondly, because the applications evolve, and every time we need to change the application, if it's one big coded application, it might be hard to perform that change. It might take time or engineering testing before we can actually put those in place. And that won't help, of course, with the faster delivery we need to do, the continuous delivery perhaps we need to do. So we need to have an approach that supports this. And of course, to reduce costs. But typically in the old way, you see that applications are one-on-one tied to a VM, to an operating system, which might not per se really use the application in the best way or use the resources in the best way. We want to make sure that it's a platform and that the applications can run on this as effectively as possible, thereby, of course, reducing costs. So typically we see is that lots of companies have currently a monolithic application approach where an app is vertically integrated, and the real skill set there is where you add new OS instances, new VMs, and then start deploying a number of copies of these apps and maybe have load balancers or what have you to really start scaling. Again, this might have downsides for changing, for continuously updating the environment, but also it might be costly because the VM in this case might be the scale unit, which is perhaps a costly unit. With the Microservices approach, we provide you with a platform, with a cluster of nodes, and top of this cluster of nodes, your application and the microservices, the small parts of your app get distributed on all these nodes, and the platform maintains it. So you don't have the burden of maintaining your operating system or storage or whatever you need. You just publish your app to the platform. It takes care of splitting them out, effectively resourcing it, but also rolling upgrades, things like health monitoring, fallback scenarios, the cluster, and in this way, the platform really takes care of it all. But of course, this needs to be a modern application. The application needs to be consisting out of all sorts of microservices that you then deploy. A traditional app might not be ready to place on these platforms. You really need to re-engineer and recode them in a microservices way. So to us, a microservice is a smaller part of this app that encapsulates a certain scenario, maybe a shopping bag or a front end or maybe some identity function. They are typically developed by smaller teams, individual coders, what have you. Our platform supports any language, whether it's Java, maybe .NET, C#, etc. And this service is contained and also has a state. It has a version, it has metadata. It's really a contained part, which then has interfaces to all these other microservices. And together, it's more or less a graph and provides you with the application functionality. With Microsoft services, you see that they are well defined with protocols like HTTP, might have individual unique naming, and of course remain consistent whenever there's failures or platform problems. Now, we see two types of microservices. We see those that are stateless and those that are stateful. Stateless can be the ones where you have a web front end that you need n times to scale because it's Christmas evening, people are placing orders and we need to scale this to support them. But there's also going to be stateful services where you have some state, maybe a mini database that contains the shopping bag information or other things that maintain data. Now, for both of them, we have the platform supports them. It's really the way on how we run them, how we scale them that's different, and we'll talk about that in a couple of seconds. So with the monolithic approach, you see vertical integration. Typically, you see these applications going out of the box, reaching out to a PaaS service like a database, what have you, getting back into the app and doing these performances back and forth. With the microservices approach, you see a graph, you see individual services, stateful, stateless. Typically, you contain them in the box, so they are very fast and very much provide you with the scale that you need. So this is one of the options you can consider, of course, to achieve the scale that you need for your business. Now, Microsoft launched a new platform, if you will, that's called Azure Service Fabric. It was became general available in May. You had probably 9 months to test it in preview, but today it's generally available, and you can run this everywhere you want. We provide you with templates and ready-to-use clusters on public Azure, which you can just deploy, and I'll show you that in a second. You can run this on your own environment. Just take the SDK, run it on your server, run it on your client, for instance, if you want to do development and have easy testing, but also on other clouds. As long as if you have access to the operating system, you can add this layer on top and provide you with the Azure Service Fabric layer. Now, the question you'll probably ask is, this is probably like Windows Server only, right? No, we're coming out with a Linux option probably later this summer, where you will have a couple of options on flavors of Linux where you can run Service Fabric on top of the Linux operating system. So that's really the new Microsoft, I guess, that's breathing there. Now, like I said, the Service Fabric layer takes care of all these things. So resource balancing, replication, low latency, rolling upgrades, what have you, all the things you normally would worry about in your operating system and in your fabric. So it's one of those things that helps you achieve scale. Now, I'd like to show you just hands-on on how that looks. And to do that, I'll log into the public Azure offering, because that's the easiest to show. For those of you that haven't noticed, there's a new portal that's called portal.azure.com, where you actually log in and see the... oh, there we go. Preview UI, there we go. So I'm logged in with my Microsoft account. I get access to the subscriptions I'm running in the public cloud Azure offering. And if I click all resources, I should see them. And one of them being the Azure Service Fabric cluster I already deployed. Not sure why this is. I think I got indeed redirected to the new portal, the new portal. Let's do this again. Go to all resources. There we go. These are the resources I'm running today. Couple of things here. The one to really note, of course, is the Azure Service Fabric cluster that I called Azure Service Fabric with a 1. Now behind this I get a default deployment, 5 nodes, and if I scroll lower I see all kinds of resources like storage accounts, the things that are used by the platform. If I click on the, there we go, on the overview page, you see the naming of the Service Fabric cluster, you see the 5 nodes, 0 to 4, and there's one application, I'll show you in a second, that I deployed to the platform that's running and that's currently in a healthy state. So that's fine. So how do I get this up and running for my environment? Well, you hit new. Of course, you'd need to have an Azure subscription of sorts. You then get taken into what we call the marketplace. They contain templates, and these templates can be multi-tier deployments of pretty much everything. So I can say Service Fabric, and it should actually come up with the template that Microsoft provides you as a starting point. And I'm running this from my 4G because for some reason the high ports didn't work on the Wi-Fi. Here's the Service Fabric cluster. You get some information. You can click on the documentation, but you can also just hit create. There's a couple of mandatory fields on naming, on access, on subscription, resource groups, all kinds of stuff. The thing you really need to consider is the sizing of the nodes underlying. You can specify a certain size of the nodes on top of which the Service Fabric cluster will run. Now this will be 2 minutes to fill in. It'll probably take maybe 8, 9, 10 minutes to deploy, and then your Service Fabric cluster is running like I had. You have an endpoint and you can start using it, and the platform itself will take care of all the nuts, all the pieces in there. Now Microsoft is running their own services on top of Azure Service Fabric. It's actually the other way around. Azure Service Fabric was engineered to run these high-scale services that Microsoft runs themselves, and they took the code, more or less reworked them so that you guys can use them as well. These are examples of the services that are running today on Azure Service Fabric, things like Intune for device management, Skype for business, Power BI, etc., etc. Now, how does the platform do things? Well, in this example, I have 2 apps. These apps consist of various services, microservices. You deploy them onto the cluster, and it will figure out where to place these microservices and make sure that they are replicated and consistent in their state. Whenever a node might have a problem, the platform, of course, itself will start moving around resources. When they're stateless, they will just spin up a new state. Now the question, of course, is how to handle stateful services. Well, more or less the same way, the platform decides where these microservices goes. It'll look at resources and other utilization to make the decision. The thing to consider here is that because it has a state, it does replication. When you write your application, you mark it as a stateful service, and it will replicate these services across the nodes in a way that the data can never get lost. Then whenever you have a problem, of course, there's a replicated service in there. To get you, to show you a bit around, here's Visual Studio, probably quite familiar to you guys. Here's a sample application you can take from Git, and there's lots of microservices in there. So there's customer-facing, reliable services. There's something about stock and stock management. And in there, there's code that's written specifically to use Azure Service Fabric. Again, this will only work if your code is really factored against Azure Service Fabric. From here on, I can just publish. So I create a publishing profile. I take the endpoint. I take the certificate or whatever you're using to secure the connection. Specify my credentials because I need to be able to gain access to that Azure subscription. And as you can see, I can just deploy it from here. And whenever you now hit publish, it will do rolling upgrades. It will check health. It will do intelligent things. If it sees that maybe a certain stateless application, microservice will fail, it will roll back and all these kinds of things. But it will just directly from here deploy into Service Fabric. Of course, there's still a way to do things manually or step by step instead of using Visual Studio, but certainly for a developer, this is a good and integrated way. Now, there's also something we call the Azure Service Fabric Explorer, which will give you more or less a dashboard on this cluster and the microservices running on those. You see, this is the public endpoint I'm using for my cluster. It gives me a bit of a heads up. For instance, on the cluster map, if I have more than 5 nodes, a couple of applications, how they're done for an upgrade domain, I can look at individual nodes, for instance, go to node 0 and say, well, I'd like to maybe restart it, pause it, and then it'll start moving out some of these apps and microservices. And again, here I can look at my apps, dive into the state, see the several services that it consists out of. So you can really use Service Fabric Explorer on top of your cluster. Now, this is what we feel allows you to take use of the platform. I guess there's pros and cons. You'd need to have an application that really works with Azure Service Fabric, but from there and that point on, you can just take the platform, deploy on top. It will take care of all these kinds of things. And to give you a bit of an example, here's a reference case, 2-minute video from a customer using it today.
We wanted to create a game of such massive scale that's never been created before.
We really wanted it to run naturally in the browsers. Anyone can play it immediately, whether it's your laptop or your phone or your PC.
We were building a system that could cope with huge demand and huge concurrency, huge availability. Around about the same time Service Fabric came about.
Say 2 alliances suddenly decide to go to war on a whim. They all meet in space at the same time to duke it out.
Our microservices in Azure Service Fabric will automatically scale up, begin unfolding space, and seamlessly distribute the load across all the nodes in the system.
We've tested it up to 50,000 concurrent players in the same battle arena. We were handling 267 million application messages a second.
Our game microservices are built using ASP.NET Core. It gives us superior performance. ASP.NET Core is open source. That allows us to contribute back to it if we have any performance issues, which then Microsoft review, and together we make a better product. Our contributions to Kestrel have reduced allocations, lowered latencies, and allowed it to be already 2,300% faster than previous incarnations of ASP.NET and more than 6 times faster than Node.js.
We run public player versus player alpha playtests once a month where anyone can just drop in. All you need is a modern browser that runs WebGL, turn up at the website, and you can play the game against other players around the world.
Cool. Although those guys were one of the launching partners for Azure Service Fabric, so I want to give you a heads up. This is what I had prepared to just inspire you on a different way on the Azure platform than just the IaaS that everybody's looking at. Service Fabric is GA, you can try it today. Just go to the portal and go to the marketplace. Any questions so far? Okay, well, thank you for your time, and I'm available next couple of minutes if you still want to ask a question.
Yeah, I just want to say a live demo on 4G that didn't fail. I mean, that's impressive.
It did work a bit, yeah, thanks.
Nice. Thank you.
No problem.